bases. Hello, welcome to another episode of Make Maths Easy. In this episode, we are dealing with number bases. Normal. What is normal? Anything is normal if we are used to it. So normal is something that we are used to. So what will be the normal way of calling out this number? Normally, we will say 3,456, and that sounds very normal. Why is it normal? Because we are very used to it. Now this is a system of base or number base system called base 10. We'll find out soon why we call it base 10. We can expand that and get 3,000 plus 400 plus 50 plus 6, and that gives us 3,456. We can further expand it. Instead of writing 3,000, we can write 3 times 1,000, 4 times 100, 5 times 10, and 6 times 1. Just because 3 is the same as 3 times 3,000 is the same as 3 times 1,000, 400 is the same as 4 times 100, 50 is the same as 5 times 10, and 6 is the same as 6 times 1. Now with this idea, we would like to introduce the powers of 10. Let us recall this. Do we remember that any number raised to the power 0 is 1? So 10 raised to the power 0 is 1. Now any number raised to the power 1 is the same one, so 10 raised to the power 1 will be 10. 10 raised to the power 2 means 10 times 10, and that is 100. And 10 raised to the power 3 means 10 times 10 times 10, and that is 1,000. 10 raised to the power 4 will simply mean a 1 and 4 zeros at the end, and that will give us 10,000. So we call the numbers 1, 10, 100, 1,000, 10,000. Can't guess the next number. The next number will be 100,000. I think I've run out of space for the zeros. I'll squeeze one here. Okay, these numbers are called powers of 10. Of course, we can see the thread. The first one being 10 raised to the power 0, 10 raised to the power 1, 10 raised to the power 2, 10 raised to the power 3, 10 raised to the power 4, in that order, and this is 10 raised to the power 5. So these are called powers of 10. Now going back here, instead of writing 1,000, we can use powers of 10 here. So we could write 3 raised to the power 3 times 10 raised to the power 3 in place of 1,000, 4 times 10 raised to the power 2 in place of 100, and this is why we say this is in base 10. In base 10, we use powers of 10, and this is what we are used to represent the place values. We use powers of 10. Now that is not the only number base that we have. Base 10, we used the powers of 10 as a place value, but we have other base systems as well. Base 2, also known as binary. But before we talk about binary, if we look at it carefully, we should know that in base 10, the only digits that are allowed are the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There is no digits to represent the number 10. No special digits for the number 10 in base 10. Rather use the digits 1 and 0, which are digits by themselves together to represent the idea of 10 or the number 10. Likewise, in base 2, which is called binary, the allowed digits are 0 and 1. In base 3, the allowed digits are 0, 1, and 2. In base 4, the allowed digits will be 0, 1, 2, and 3. Now, if you want to write a number in base 2, because we are so used to base 10, you would have to indicate by bringing this tiny little 2 right here to tell us that this number is not 1,011, brother. It's called 1011 base 2. You could decide to write it this way with a 2 in words. Now, so instead of using base powers of 10, we use powers of 2 in base 2. So the number would rather be presented this way. It means the place value of this one here is 2 raised to the power 0, and the place value on the other side is 2 raised to the power 1. Place value here is 2 raised to the power 2, and the place value here is 2 raised to the power 3. Unlike base 10, which had 10 raised to the power 0, 10 raised to the power 1 at the tenths, 10 raised to the power 2 for the hundreds, and 10 raised to the power 3 for the thousands. So you could call this ones, you call this twos, you call this fours, and you could call this eights, because 2 raised to the power 3 is 8. If you would like to convert this number to base 10, which we are used to, you have to write it this way. Just multiply the place value plus the date in that place. So 1 times 2 raised to the power 3, you can group it in a bracket, plus 1 times 2 raised to the power 2. Then I proceed. 1 times 2 raised to the power 0 for the middle number. Then I could proceed and have something like this. So we could simplify and get 11. So this simply tells us that we don't really have to write 10 to show that it's in base 10. Usually we write just this. So this tells us that 11 in base 10 will have the same value as 1, 1, 1, 0, 1, 1 in base 2. Just write that out. Then how do we prove that this is true? We can prove this by rewriting it this way. Now we can prove this by converting 11, which is in base 10, to binary, that is base 2. How do we do this conversion? This time around, you are going to make use of division. So just draw these two lines. R standing for remainder, and this is how we go from it. We go by it. First of all, we have to ask ourselves, how many times can we get 2 in the number 11? Or how many times can 2 divide 11? So you can do this simple illustration if you struggle to understand this. The number 11 is represented by these 11 bars. As you can see, I can get 5 2s from this. This is 1, 2. This is another 2. This is another 2, 3, 4, and 5. And there is 1 which is remaining. So I can say that if 2 goes into 11, I'll get 5, remainder 1. So I'll just put it out here. The next step is to do the same thing. Now you ask yourself, how many times can 2 go into 5? 2 goes into 5 2 times, remaining 1. Then you proceed with the same step. How many times can 2 go into 2? 2 goes into 2 just once. That's 1 time. Write the 1 here. This time remaining 0. Write the remainder here. Then finally 2 goes into 1, 0. That means you cannot get any 2 from 1, but you will only get a remainder of 1. Okay, so you write this out from the bottom to the top. That's just exactly how the arrow is showing. So I'm going to write 11, which is in base 10, so no need to write anything down here. Will be the same as 1, 0, 1, 1 base 2.